So how do we debug our code? Well, remember, debugging means that we're fixing any problems in our program, because a bug is an error in our program. So we want to debug our programs. We can do this in a number of ways. So I'm just going to write a simple little program here. We'll go over what it does in future lessons. It's not really that important. I'm going to say int num is equal to 5, and then I'm going to display that number, system.out.println num. We'll go like this. Number. Okay, so this is a very simple program. If I run the program by using the F11 key, it shows down here number : 5. Okay, doesn't do very much. It's a very simple program. Now, if we run into a problem, let's say I delete that semicolon. Okay, save my program, and I hit the F11 key to run my program with debug. It's going to say, hey, there's a problem. Do you want to, so there's a problem. Do you want to proceed with the launch? No, we don't. We're going to hit cancel. And we're going to go down into our error log. And down in our error log, in theory, it should be showing our errors. This is not, oh, sorry, not the error log. It's the problem section that we want to look at. This is what I want. Down in the problem section, we see that there are warnings and errors. We're going to ignore the warnings. I don't really care about those right now. What I do care about is this error. And there is only one error right now. There may be many errors in your program. Rule of thumb, always start with the first error, because some of the errors below it may not actually be errors. They're just presenting themselves as errors because of the earlier problems. So for example, if I break this command down here, that means this never happened, which means this causes a problem because this doesn't exist. Alright, so it can cause future issues. So we always start with the first error and work our way down. How do we fix the problem? Well, a number of different ways. We have to work our way through. We got to do some problem solving. First thing, it tells us where the error is. Line 10. Well, that doesn't help me that much, except for the fact if I click on the lines down here, this is our status window. We can actually see what line number we're on. So if I click on here, it tells me I'm on line 10. If I go down one line, I'm on line 11. And it tells us that the error is on line 10. So we know there's a problem somewhere on this line. Another way of getting to the error is you can just double click on there and it will highlight the line and where it thinks the problem is. This little command here, or this little statement here, tells us what it thinks the error is. Syntax error. Insert semicolon to complete the statement. Okay, it's telling me that I need a semicolon. Well, as we're going to learn later, all Java commands require a semicolon at the end of their line to actually work. Commands, that is. Think of it like a period at the end of a sentence. Now, alternatively, you can see that there's an error on that line in a number of other ways. First of all, it shows up as an X on the left, and there's a little red rectangle on the right. So if you're working in a 10,000 line long program, and yes, that may be the case, you can just put your mouse over it, and it'll tell you where the error is, and you can click on it, and it'll bring you right to the error. If you mouse over this one, same thing, it'll tell you where the error is. Very useful tools. So they're all telling us how to solve the problem. This is fantastic. So I hit my semicolon on there, and it fixes the problem. We notice that turned white. The red ran away. Now if I try and run the program without saving, it's going to say, hey, do you want to save first? Yes, I do. Thank you. And then it runs the program, no problem. So that's one way we can actually fix our programs. And that's a very reactive way. We're reacting to the problem. However, sometimes there may be a more proactive choice, and this means finding the problems where we think they might be before they actually occur. In order to do this, we're going to use the debugger tools. And the number one tool in the debugger toolbox is a breakpoint. A breakpoint is like a pause point in your program. You know, when you're watching a movie, you can pause at a certain location. We can do the same thing in our code. Now remember, our code runs from top to bottom. So in this case, we only have two command lines, int num equals 5 and outputting number : num. So if I want to add a breakpoint, over here in this far light gray area, now it's highlighting the blue because that's where all my logic is, but on this column here, if I double click on one of the lines of code, it will create a breakpoint. We see this little blue dot. And this is a pause point. So if I run the program in debug mode, it will say, do you want to switch perspectives to Java debug perspective? Yes, I do. Thank you very much. and it actually pauses the program on this line. It hasn't executed this line yet. I'm going to jump over to the variables tab up here, and we can see that no variables have been created yet. Now if I want to execute this line of code, I can do so with the F6 key. So I just tap F6 and we'll execute that line of code. Now you'll see that the number variable actually popped up over here. So num now exists. It's been stored in memory. Alternatively, I can just put my mouse over top of that little variable and it'll tell me its current value. Very useful tool. If I put my mouse over top of any command, it tells me what that command does. Prints a string and then terminates the line. Okay, great. So this is what the debugger does. It gives us information on the fly as the program is running, making a very, very useful, helpful tool to fix any potential issues. So now I'm going to stop the program using the terminate, the red square, and I'm going to run the program and debug again, but this time I'm going to take away the semicolon. Or sorry, no, I'm not going to take away the semicolon. Let's, how else can I break this? What's another syntax here? Let's say, we'll do this. Num is equal to num divided by 0. Now if we run our program, yes, we want to run it. It's telling me that there's already an issue. I can't divide by 0. That's not what I wanted. Anyways, that's fine. Let's just step through the code, and we're going to go through piece by piece, and what you're going to see is that we can actually go through the entire program like this, or you can just actually just let it go, and then you don't have to worry about anything. It'll just keep going until it hits another breakpoint. You can have as many breakpoints in your program as you want, because as your program gets bigger and bigger and bigger and more complicated, it may be useful. Yes, I want to run it again into the debugger view, and again I can step through with the F6 key. I can also use the F5 key, and what the F5 key does is the same thing as the F6 key, except if it's on a command that calls some of the support code, that uses some of the support code, it will jump into the support code and execute that code as well. If we use the F6 key, it just executes it without going into the support code. So this may or may not be useful, or may not be what you want. So as we step through the program with the F6 key, it keeps going down until it finishes. And once it's all done, it's just kind of exiting the program. We can't really do anything about that. If we want to continue until the program is done, we just hit resume, or F8, and the program will go as normal. Now let's say we want to get back to the regular view. All you have to do is click Java, and we're back. No changes, no harm, no foul. Very easy to work with. How do we get rid of the breakpoints? Just double click on the circle again, and you're back to normal. Again, you can have as many as you want. It's kind of silly to have them line after line, but it depends on what your purpose is. Sometimes that may be useful.